Notes 5.4 are going to get into naming ionic compounds. Once again, you are going to need your periodic table throughout these notes. Before we get into how we name ionic compounds, just some background information about the system of naming we use. When we name chemical compounds, we use what is known as the IUPAC nomenclature. IUPAC stands for the International Union of Pure and Applied Chemistry. It is an international organization that sort of oversees or regulates all things chemistry related. And what this is a systematic approach to naming compounds. So the term systematic means that once you understand the system for naming compounds, you can then name pretty much any of the chemical compounds that are out there, instead of having to memorize the names. So there is a system in which chemical compounds are named, and that is what you guys are going to be learning, is what this system is. Because this is an international organization, the names that we use are the same names everywhere. Many of the substances we work with, especially in a first level chemistry course, have common names. Things like baking soda, quicksilver, lye, laughing gas, etc. The problem with common names is that common names do not tell us anything about the chemical composition of the substance. And as a chemist, that is what we are concerned about, the numbers and types of atoms that are found in a compound. And so if I were to tell you that baking soda has a chemical formula of NaHCO3, you now have a better idea of the atoms that make up baking soda and therefore the chemical composition of baking soda. If I were to give you the chemical name for baking soda and tell you baking soda is also known as sodium bicarbonate, once again, you now have a better understanding or a better idea of the atoms that make this compound up. And so common names are not very useful in chemistry. So, moving on to naming ionic compounds. The first type of ionic compound we're going to talk about naming is a binary ionic compound. Okay, the prefix bi means two, and so by definition, a binary ionic compound is a compound with only two different ions. So the binary part of the name refers to the fact that there are two ions. The ionic part, as we've talked about with ionic bonding, means that one of those ions is a metal, one is a nonmetal, or we could say one is a positive ion and one is a negative ion. So if we think back to writing chemical formulas, when we wrote chemical formulas, we wrote formulas in which one of our ions came from the positive side of that chart, one of our ions came from the negative side of that chart. And so the system of naming for ionic compounds is going to be such that one of the ions is going to be a metal, one is going to be a nonmetal. When we name binary ionic compounds, we want to name the cation and the anion separately. Okay, remember when writing the formulas, the cation or the positive ion goes first. So when we name binary ionic compounds, the name of the cation is simply the name of the element. Okay, once again, no memorization. You can use your periodic table. And so if I asked you to name Ca, we could look that up on our periodic table and see that Ca is calcium. So the first name in our chemical compound will always be the name of the element. Okay, the anion in our chemical compound is going to be the name of the element with the ending in IDE. So we're going to change the element name and add an IDE ending. So for example, if I were to look up oxygen, on the front side of my periodic table, I would see that the element symbol O is called oxygen. However, if I look that up on the back side of my periodic table, okay, I find O2 there, I see that O2 with a -2 charge is called oxide. Okay, the same can be true of fluorine. On the front side of the periodic table, the element F is called fluorine. However, as an ion or a -1 charge, if I locate it on the back side, I can see fluoride is the name of it. And so if we use this table on the back of our periodic table for our naming purposes, the names that we see on that chart have already been changed. And so there's no need for us to change the ending. The only thing that can be a little tricky about naming binary ionic compounds is if your cation has more than one oxidation number. Okay, so what do I mean? Well, there are certain elements on the periodic table that can have multiple oxidation numbers. Remember, oxidation numbers are those numbers that tell us what the charge of that atom will be when it gains or loses electrons in order to get to its full outer shell. If you have an element such as iron, Fe, iron can have multiple oxidation numbers. And so on the cation side of this chart, if I go ahead and I look for iron, I see iron can have a +2 charge, or iron can have a +3 charge. And so if cations, or if the cation you are working with has more than one oxidation number, we're going to use Roman numerals to indicate which one. So for example, Fe+2, I would call iron, and then in Roman numerals, do the Roman numerals 2. Okay, if I were working with iron that had a +3 charge, I would name it as iron, Roman numeral 3. Okay, this only affects cations, or positively charged ions. We will never have negatively charged ions with multiple oxidation numbers. If we take a look at the chart here, then we can see there are a couple of other elements that appear multiple times. Okay, so if I look, I see chromium can have multiple oxidation numbers. I see arsenic. I see lead, copper. Okay, so anytime you're using the backside of your periodic table, if you see an element that is listed multiple times, then you need to determine what the oxidation number or what the charge of that ion is, and make sure to include the Roman numerals in the name. Okay, so let's, first one, nice and easy, MgO. Okay, so when we name this compound, we're going to separate out our compound into its cation and its anion. So if I were to look at this compound, okay, Mg is the cation. I know that because it's found on the cation side of my chart. I could also tell that because it's listed first in the chemical compound. When we name this compound, then the name of the cation is simply the name of the element. So if I look, Mg here is called magnesium. So the name of, or the start of my chemical name is going to be magnesium. Now I'm going to go to the right-hand side and I'm going to find O, which is my anion, and I see that O is called oxide. And so the proper name for the chemical compound MgO is simply magnesium oxide. I am taking the name of the cation and the name of the anion from the back of this chart. Okay, let's look at a little more challenging of one. Okay, let's look at FeCl3. So once again, these are all examples of binary ionic compounds because they all contain only two elements, in this case Fe and Cl, and one of those ions is positively charged and one of them is negatively charged. Okay, so if I look, Fe, on the back side of my periodic table, I see that iron is listed a couple of times here. So that's going to tell me that I need to use Roman numerals. So when I name this element, I'm going to start with the name iron. Now what I have to do is I have to figure out what charge this iron atom is containing or is carrying. And so to determine the charge of our cation, we're going to look at the anion. If I go over to the anion side of my periodic table, I can find chloride right here. And I see that the charge of a chloride ion is -1. So each chloride ion in this compound is carrying a -1 charge. I have 3 chlorides, so the overall charge of my compound, or the overall charge of the chlorines in this compound, are -3. Remember, when we wrote formulas, the idea behind writing our formulas was that we had a overall charge of our compound being 0. And so if the negative ion charge is a -3, then that's going to tell me that the iron here has to have a +3 charge in order to cancel that out. And so when I name this compound, I'm going to name it iron Roman numeral 3. Okay, now we have to go to naming the anion. Again, the anion is Cl. I find Cl over here. I see it's called chloride. And so I simply copy the name exactly as I see it. And so FeCl3 has a chemical name of iron 3 chloride. Okay, for our last example, we're going to look at PbS. So let's find Pb on our periodic table, and we see Pb here is lead and that it is listed multiple times. So we know that the name of our cation is lead, okay, but we have to determine which lead we're working with. Are we working with lead that has a +2 charge, or are we working with lead that has a +4 charge? Again, to determine the charge of our lead, we're going to focus on our negative ion, which in this case is S. I go over to the right-hand side of my table here, and I locate S. I see that one S atom, or one S ion, has a -2 charge. Okay, according to my chemical formula, I have 2 of them. So -2 plus a -2 gives me an overall charge of this compound of -4. That means that the lead that I'm working with has to have a +4 charge in order to cancel that out. And so when I go to write the chemical formula then, I know that lead has a +4 charge, so when I name it, I'm writing lead Roman numeral 4. Okay, the name of the S then is simply sulfide, so the name of PbS would be lead 4 sulfide. Again, you want to be careful when you're using this chart. Make sure that you're using the proper ion. So S here is sulfide, but notice there's sulfate, sulfite, so you want to make sure you're using the correct one. So that's how we name binary ions. The last thing we're going to talk about are naming ternary ionic compounds, and ternary ionic compounds are simply compounds that contain those polyatomic ions. Remember, polyatomic ions are ions that are made up of more than one atom. When we name ternary ionic compounds, we're going to separate the cation and the anion again and name each one individually. Once again, the name of the cation is the name of the element, the name of the anion is the name of the polyatomic ion. So if I were going to name the compound CaCO3, I first have to decide where my cation and my anion are separated. Okay, Ca is the cation here, and so Ca, if I look it up, is called calcium. CO3, I need to recognize as being a polyatomic ion, so that entire thing has one name. Okay, and if I look it up on the back side of my periodic table, I see CO3 is called carbonate. And so the name of CaCO3 is calcium carbonate. Okay, in my second example, I have MgNO3 Again, I have to figure out where my cation and my anion lie. My cation is Mg. If I look up the name of Mg, it is magnesium. I want to recognize the NO3 as being one thing, and that entire polyatomic ion is called nitrate. So the name of my compound is magnesium nitrate. Okay, my last one, Na2SO3. Na is my cation. The name of it is sodium. SO3 is my anion. If I look it up, it's sulfite. So I end up with sodium sulfite. Recognizing polyatomic ions can be challenging. What you want to remember is no matter what type of compound we are naming, there should only be 2 words in the name. So for example, carbon and oxygen shouldn't be named as carbon oxide. Okay, that entire thing has the name of carbonate. The more practice you get with naming compounds, the more familiar you will get with all of the polyatomic ions.